And good afternoon, everyone, and welcome to our final webinar in the Manufacturing a Greener Future series. I'm Greg, and I work with Aineias in the Manufacturing Skills Academy, and I'll give you a quick introduction before I hand you over to our speakers for today. Before we get started, got some quick housekeeping to cover over. This webinar is being recorded and will be made available on our YouTube channel once the session's finished. Your microphones and your webcams are going to be turned off during the session to avoid any background noise, but feel free to type your questions throughout the session into the chat tool, and we'll pick these up at the end of the session. So time will be allocated at the end to give our speakers time to answer any questions that come through, and feel free to use the hashtags that are up on the screen just now for any questions on our Twitter page as well. Just leave that for a moment to get you a second for that Twitter handle. And as I mentioned, today's session is the final session in the Manufacturing a Greener Future series. The previous webinars were an introduction to sustainability and an introduction to Industry 5 and its role in sustainable manufacturing. Both of these are available on our Aineias YouTube channel for anyone that wasn't able to attend or for anyone that wants to view these again. We'll pop that link into the chat, and you should be able to link directly to our YouTube page from there. These events are part of the Advancing Manufacturing Challenge Fund and the Low Carbon Challenge Fund and are funded by the European Regional Development Fund and Scottish Government. Today's session will look at will not look at Industry 5. Today's session is going to look at life cycle analysis and how it can be used to assess the environmental impacts across the life cycle of a product or a process. We're going to give you a bit of an introduction as to how to use the lifecycle analysis tools and discuss the various software solutions, and we're going to look at a case study as well. Today's speakers, as in previous sessions, we're joined by Professor David Butler from the University of Strathclyde and the Extend project, and we're also joined today by one of my colleagues from Aineias, who will deliver part of the session for us as well. Just before we move on to today's session, wanted to give you a quick rundown of some of the support that's available from the Manufacturing Skills Academy to support some of the information that we're going to talk about today. We've got a number of training packages online where you can look at other sustainability topics, including the life cycle analysis that we're going to touch on today. The Manufacturing Skills Academy here in Aineias is here to develop current and future workers and help enhance their skills and that their employers need to compete globally in manufacturing. As I mentioned, we've got an online portfolio of digital training covering a range of different digital manufacturing topics and leadership topics. And we also offer a range of more bespoke services, including one-to-one support and consultation. We can run bespoke workshops for your businesses in continuous improvement, Lean Six Sigma, remanufacturing, design and innovation, equality, diversity and inclusion, just to name a few. We're also embarking on a project with the local Knowledge Transfer Partnership Centre to help build capacity within Aineias for KTP projects. So it's a really good opportunity to get involved in some significant projects through that fantastic KTP scheme. I'd be happy to discuss that with anyone who's interested in finding out some more. And again, we can provide signposting to further organisations with our partner organisations where you can get some further support. So all our support in the Skills Academy is free of charge to qualifying SMEs. The link on the screen just now will take you to our course pages where you can sign up and tackle any of our online courses. And obviously, if you want to discuss any of the one-to-one support, feel free to contact myself via the email address that's on the screen. I'll also pop these into the chat during the session today so that you can make a note of them if you want to drop me an email. One final point before I hand you over to our speakers, we're also planning an in-person event focused around sustainability and remanufacturing. We're hosting this event at Halo Labs in Kilmarnock on the 14th of March, and we've got lots of interesting speakers and workshop sessions to get involved in. So if you'd like to sign up, you can find details on the Aineias events page as well. And without further ado, I'll hand you over to David Butler to dig into life cycle analysis. Thank you very much. Enjoy the session.
Thank you, Gregor. I'll get Aineias, you can share the slides, please. Technology. Is it sharing, or am I just looking at the wrong screen?
Yeah,
No, it's not showing up.
Don't see them, David.
Okay, it's always a sanity check when you're presenting, isn't it? Right, and now I need to take control, I guess. Okay, that should be it. Right, a very good afternoon. As Gregor mentioned, I'm David Butler. I lead the Extend project, which, like most of these projects, is European Union funded and is there to provide fully funded support to SMEs in Scotland, helping them on their journey, particularly towards net zero, and also actually finding opportunities in the supply chain for them to go into new businesses. So we do quite a lot of things such as energy reporting, and from that we move forward with value stream mapping, signposting, and Aineias is one of the most active in the team looking at the life cycle assessment for companies. So we put together a presentation. You see 3 names here. Lee Patterson is part of the team. Lee will be around for answering questions, but also I think she'll be very busy on the chat as we go through in case anything comes up which needs immediate response. So without further ado, I'm learning the system for the first time with the shared files. We got quite a bit of things to cover. First of all, just to recap on what NetZero is, it's been blowing hot and cold. With COP26, it was all in the news. COP27, not much was said. And there's been a lot of questions about, is the UK particularly on target to achieve their net zero ambitions? We'll also recap it on the circular economy. These have all been covered in more detail in previous webinars, which are available on the link which has been put into the chat. So there's a whole channel of YouTube videos we put together covering a lot of topics in a bit more detail, but this one really is focusing on the life cycle assessment. We'll introduce that. Why bother? It's one of those terms getting a lot of attention, but is it really important? And Aineias will go into a lot more detail about what it is, how it can be used, and also an example. So we decided to look at beverage packaging because it's a common one. Is shops opened which actually bring your own container rather than actually having go on there and then dispose of it. And there's a lot of push against single-use plastics. So I think that's quite a topical example, and it gives you an overview of the kind of activities you need to do and the kind of information you require to make a valid decision on whether you should change your packaging, for example. So I think that'd be quite good. And we finish off a bit like what Gregor said about the kind of support available to help companies on our journey. And also we do a lot of signposting to other organizations. So a big recap of net zero. I actually found some papers academic papers which seem to say there's so many different definitions of what it is, but really net zero is focused on carbon, and it's really carbon net zero, and that's because we needed some kind of equivalent to a monetary unit, and carbon was seen as the one which captured politicians' imagination, and it becomes like the base unit. So everything is equivalent, carbon dioxide equivalent. It doesn't just, we talk about net zero, but we actually talk about more than just carbon dioxide. We talk about all greenhouse gases and how to reduce them. But it's just like I said, the attention and the media interest is mainly focused on carbon dioxide. But really what we're trying to do is we're trying to balance our processes, trying to actually get to the stage where we're not contributing to the environment, which is probably more of an ambition than a reality. But if we don't move towards that direction, we're going to have problems. And we're looking at greenhouse gases. The most common ones there are the methane, nitrous oxide, and of course, in the old days, we had all our fridges full of CFCs, the fluorocarbons, which were the big issue in the 80s and 90s. But all these can lead to trapping the heat and, of course, global warming. So this is why these particular ones have got a lot of focus. And when we are doing calculations on, like I said earlier, what is our measure? Our global warming potential is based on carbon dioxide. So that's the measure which we all look at. And when we go to companies and analyze either their process or product, that's what we come out with, a carbon footprint. So the amount of carbon dioxide, equivalent used to produce either that product or for the whole processes. So it depends on the kind of organization. So you'll see the term throughout these presentations, CO2e, so it's carbon dioxide equivalent. It's just a metric we can all use. And a bit about the circular economy. There's 141 definitions which I believe of what a circular economy is. And as there's no standard, it's really subjective to different industries and people. And there is this expression called greenwashing. where you can make things sound as great as you want to appeal to your audience, and that's what's going to have to come out in the next few years when we try to standardize things so we don't get this miscommunication. You know, some people say electric vehicles are fantastic, others say they're not because of the life cycle. It depends which lenses you look through when you describe these different products. So really, what we're trying to do with the circular economy is ultimately stop taking anything else out of the environment, stop mining, stop extracting oil and refining it. Can we reuse our material? And that's the real challenge of the circular economy, is how do we get towards that? Because the current linear economy is you take it, you mine it, you process it into a product, you use it, at the end you dispose. And of course it goes to waste, and it could be landfill, hopefully a bit of recycling, but ultimately there's waste all through the process, and there's a lot of inputs as well. So it's a very simplistic way of looking at it, but this is your traditional economic model. The circular economy is slightly different. So this is a combination of the bio on the left-hand side and more about, you know, the manufacturing on the right. But really, as you go further away from the axis down the middle of the collection, each of these, such as maintaining, requires the least energy. As you get to recycling, that's where the most energy. So the most desirable is having the shortest loop back and to reuse the product. And in Inmis and Strathclyde, we do a lot of activities around remanufacturing, trying to extend that life of the product while giving the same guarantee of its performance. So there's a lot of companies we help in that area, and that's one of the more desirable ways to promote the circular economy. Ultimately, going forward, selling products will never be truly circular, but selling a service is probably the way to go forward. So you don't buy the product, you rent the product, just like we do with software at the moment, and bicycle sharing in most large cities in the UK. So the LCA, I believe this is when I'm going to pass over to Aineias to take over for this section.
Thank you very much, David. So what is an LCA? To begin with, according to the definition, an LCA studies the environmental aspects and potential impacts throughout a product's life cycle. So where does that start? It starts from the resources all the way to material processing, product manufacturing, distribution, use, and end of life. As you see, there are multiple stages, and across all these stages, we should be able to capture the input and output. The general categories in which we use to quantify the environmental impacts usually are the resource use, the human health, and the ecological consequences. So what should an LCA include, and what are its applications? Generally, an LCA should include a full assessment of each stage. As we saw before, each of these stages has specific inputs and outputs that we all have to capture. That, of course, includes all upstream and downstream aspects. And of course, as an example, it could be the source of electricity that we use for powering a machine, at processing, the polluting emissions, transportation, and many more. Applications, there are multiple applications for a life cycle assessment. Some of the categories are there, for instance, the product development and improvement. A good example is every product design decision that we make based on environmental data. We would need some information from the LCA. If we want to have strategic planning, a good example would be that the focus specific. Is there an issue with the?
I don't think so. Is everybody else connected okay? Did you lose connection?
I've got no problems at my end.
I think it was just yourself, Russell. We can hear you fine, but you can catch up on the recording if you've missed anything.
All right. Apologies for the break. I thought it was something on my end.
No, I don't think so.
Continuing, and one of the many applications is that strategic planning. For instance, companies that they want to focus on specific products with less environmental impact. Public policy making, we hear it multiple times. What is the best way to achieve our sustainable goals? And how can you do that if you don't quantify what those goals are? Marketing, this is one of the best applications of LCA for companies because it attracts new customers. It helps them enter new markets or even create a brand for them. And of course, others such as the push for regulations, push for new industry standards and many more. So as you see, there are multiple applications of an LCA. Why is it important? As we slightly touched upon, being able to quantify the environmental impact is crucial in order to be able to identify the industrial processes and the impact they have on the climate change. Generally, we have agreed that due to the industry's human activity, climate change is becoming more and more of an apparent issue over the years. So it's crucial to be able to quantify and create a benchmarking in order to be able to understand what your company is doing and how can it align with the governmental policies. As well as governmental policies, I'm sure you're familiar with the 2015 Paris Agreement, which set a worldwide target for in order to reach net zero emissions. And later in 2021, COP26, we saw Glasgow taking huge initiatives there and being able to, and many companies used that momentum of COP26 in order to set their own net zero targets. So a global example, the only countries in the whole world up to now, it's Bhutan and Suriname, that they have managed to achieve their global net zero targets, and actually they're carbon negative. That means that they remove more carbon than they actually produce. And then we go to Uruguay with a goal of 2030, Finland 2035, which is of course helped with geothermal electricity. Then we got Austria 2040, Germany, Sweden, and Scotland 2045. The rest of the world, I would say it's mostly 2050, the goal for net zero. And then we have China 2060, India 2070. And I believe the last one is Singapore, that is not in the map, it's 2100. So in order to reach those global targets, we have and achieve the neutrality, there are specific areas that we really have focused upon. And this is clean transportation and energy production are considered to be key enablers. The UK government has set a ban on new diesel or petrol van cars from 2030 and even hybrid vehicles from 2035. So as I said before, a life cycle assessment is able to support these decisions and quantify the environmental impact for those decisions. They have also introduced a new target of producing enough renewable energy. And there are multiple other initiatives, such as the Fly Zero initiative, that it's a project that David has worked upon, and it's focused on low emissions flights. So what is the common thing between all those? Of course, it's measuring, and we need to be able to measure climate change, carbon emissions, pollutants, in order to have benchmarks and to be able to quantify what we're doing and how we're doing it. And this is exactly where the LCA comes in. As you see, there are multiple pollutants, multiple greenhouse gases. Of course, we're talking usually in CO2 equivalent, but that doesn't mean that this is the only thing that we take into consideration. And for the next slide is David.
Okay, so what can this all be used for, the LCA, and also we're going to talk a bit about what is carbon accounting. So just give you a few definitions first. And really, it can vary in definition. So carbon accounting, it's a term thrown a lot in LinkedIn, for example. It can vary in how you define it depending what you're focusing on. So the process, it can calculate an individual person's or an organization's emissions, but it can also be the word accounting, we can actually relate it to the finance as well. So there are things like carbon offsets, there are carbon credits. So there is a way to actually try to equate the carbon value to something more monetary, which of course makes accountants very happy and also helps focus certain sectors on the cost of carbon in that respect. To report on your carbon emissions is becoming mandatory. So far about 40 countries have signed up to some kind of agreement. And this is where the challenge is. There is no international standard at the moment. There are methods and methodologies out there, but two companies could work together to similar products, but report differently on how they actually achieve or actually how they calculate their carbon. So that is one of the big problems at the moment. It's not standardized. There is a push towards that. So we just, I described yesterday at a meeting as the Wild West. There's a few things out there, everyone's trying to find out which is the de facto standard. It will come very soon. But we also have the carbon footprint, and the life cycle assessment is one way of trying to achieve this and give you a meaningful value to what what is your output? So there is a question here to ask, which is really, is the life cycle assessment and carbon footprint the same? And the best way to explain this is in the graphic. So there's a difference. If I look at graphically, in the middle, life cycle assessment covers a lot more than just the carbon footprint. We can also look at other factors, the full cycle. We can look at the water deprivation, how much water is being used, and there's a lot of reporting recently about the production of lithium batteries, or extracting lithium for the lithium-ion batteries, and how much water is required in certain places like Bolivia to get the lithium out. So suddenly it's not just about the mining, it's also about the the actual refining as well, and water is one of those that comes up. And you can see acidification. Many years ago we also talked about acid rain. Very rarely hear that mentioned these days. Ozone depletion, that was the thing in the 80s. We don't refer to the big hole in the ozone anymore, but of course global warming is there. So life cycle assessment covers a lot more than just carbon footprint. I think that's very important because it depends who you're reporting to, and you do sometimes want a much fuller definition of what it is than just one single metric, which is the carbon footprint. Carbon footprint is convenient, it's a nice thing to quote, but of course it's a bigger problem than just that, and we need to look at all these factors as well, depending on the kind of process or product you're producing. We also have something called environmental product declaration, or EPD for short, and this is a way to show more transparency. It's very useful because it's objective and you can compare between different products. It does cost a bit of money because everything has to be third-party verified to show its authenticity, and also to avoid any bias. But it does talk about your product or your services' environmental performances, and it takes the whole life cycle from cradle to grave, or cradle to cradle, if that's the way you look at it. And to get to this, your starting point, yet again, is life cycle assessment. You can't get away from the fact you need to capture lots of information about your product, its usage, where the material comes from, the disposal, put all that together to actually use that to make something meaningful. I mean, you can actually categorize the performance of your product in terms of environment. We also have something called product category rules, or PCR. I know PCR means different things in biology, but it's a way of actually defining the rules, requirements and guidelines for a particular product, so you can actually ensure that it does follow some clear definitions and clear steps to defining what is the environmental product declaration. So already we talked about carbon footprint, we talked about life cycle assessment, we talked about EPD. You can see there's a lot of different ways out there because it is a very complicated topic. You can make the amount of information you need, the way you can present that. It's very important to understand for different sectors, for different applications, and for different reporting authorities, you need to show a different level of information and fidelity. I've got an example here. It's just a very simple example put together. I didn't draw this. I stole it off a free software. But anyway, imagine a way to look at it is looking at two car companies. So we have the Eagle Car Company, beautiful car, nice design, classic, sells very well, petrol or internal combustion engine in there. And they got a plan. The Eagle Car Company wants to go net zero, and this is their ambition, and they're going to tout it on their marketing in a year's time. So when we start looking at the life cycle, the kind of things we can look at, we can look at the process. So we have different types of emissions. We can actually categorize. Scope 1 is really linked to what the process is. So we have the factory, it's producing the cars. Maybe we decide to stick some solar panels on to try to reduce it. So we know that we've got forging, we've got metal stamping. It takes a lot of energy. Maybe to offset that, we go, okay, solar panels. Okay, we live in Scotland. Solar panels may be the best solution, probably wind turbines, but this immediately will get rid of all our emissions, well, almost everything. We do realize forging, maybe we need to, that's a lot of energy, maybe we need to plant some trees. And this is where it gets very worrying. Companies go, we're going to offset by planting trees. It typically takes 20 years for the trees to get to maturity to actually start capturing carbon. So when you hear about this, it's always a bit suspicious. In fact, EasyJet has recently changed their policy. When you fly EasyJet now, they would tell you they're not investing in carbon carbon capture solutions or offsetting. They're now investing in technology for the next generation to try to reduce their carbon footprint. So there has been some companies who have changed their mindset recently and accept that you can't just offset. So this company is claiming now that the factory's net zero. We've got the production, we've got the solar panels, we've got the trees, we are a net zero company. And that's great, but that's only one part of it. That's the scope 1 emissions. And that probably, producing that car is equivalent to 5% of the life cycle of the car. Now, cars, of course, as mentioned earlier, it's petrol. It's going to be using lots of fuel during its lifetime. That's not the company's fault problem, but if you look at the whole life cycle, it is part of it. So the manufacturing only makes up a small part. Majority is going to be operation, and when parts need to be replaced, that's how are those from a sustainable source. So it's a highly simplified way of just looking at a very, very narrow focus to say we're a carbon neutral organization. Now, Osprey has decided to go for electric vehicles. It's great. Looks nice and very nice design as well. It's going to sell well. So these are going net zero. This is the way forward. And they're thinking a bit more holistically for the factory. Similar solutions. We've got to reduce our type 1 emissions, scope 1 emissions, sorry. So what we're doing is we're going to look at trying to make this factory as net zero as possible. Try to balance our inputs and our outputs. And we know that's our direct emissions. But if we're being honest, maybe we won't get complete efficiency. We still need power. The question is, who provides it? Is it from a clean energy source, or is it from coal-fired power stations, for example? So we start expanding beyond just scope 1, what we directly produce, but also scope 2, and ultimately, and this is where the challenge comes, is the third one, scope 3, which is all indirect emissions. And this is when the car's being run, the pollution, that's an emission. When you have to replace parts of it, or the materials used by your subcontractors, all those would have emissions. And this is where the challenge is for most companies now. The larger companies are making big announcements. We're going to be net zero. And to do that, they are forcing it down through their supply chain. And that's where most companies will be directly affected, not because they're pushing net zero themselves, but then being compelled by their customers to demonstrate their net zero ambitions, the journey, and also demonstrate their emissions. So this is why suddenly everybody's talking about life cycle assessment. You keep hearing scope 1, scope 2, and more importantly, scope 3 being mentioned, because we've got to address all these as we go forward. There is a parallel to this, and it's back to the 90s and in the 2000s is when ISO 9000 came out, the quality standard. And suddenly the big companies were telling their supply chain, you all need to get on board, you all need to be accredited for ISO 9000. And it caused, down for the supply chain, the same happened. Every company had to improve its quality, or at least demonstrate that it was traceable and that it had documentation to prove it. So it's a similar here as well, but this time, of course, it's more about the environment, less about purely on the quality, but worth mentioning. The Osprey car company also has plans eventually to recycle material and make their hard products out of it. So initially, they're looking at the scope, but longer term, they're planning to have a recycled vehicle in terms of the material usage, and also look at more efficiency. So they can do that as well. And ultimately, I already said they're only looking at their factory. Remember, Osprey is the one producing petrol cars. They will switch possibly to electric vehicles. That's part of the plan. And that's what's happened to a lot of companies in the world. The car companies have quickly reacted and switched to electric vehicles because they know how to build cars. The only difference is the power plant. And the Osprey's net zero plan is really, apart from what we said before, is actually to go further and target their material providers to make sure all those companies are following a similar pattern of reducing their carbon footprint and so on. And eventually you're going to get more, if not, you lose your suppliers and you get more greener material providers. So it's a big impetus on companies to actually make an effort. And going forward, these net zero plans, of course, it's going to proliferate out into the whole supply chain. So everyone has to get on board. So it's just the start of the journey. So a lot of work to be done. I shall now pass back to Aineias to say how we actually do it.
Thank you, David. So we saw the big picture, and now we want to quantify the environmental impact of our product. So how do we use it? Well, the first thing to identify is the goal and scope. It's the first step defining is what exactly is to be analyzed. There is a side of the ISO standard I 14040, which include 4 key stages: the intended application, the purpose of the assessment, the system which is assessed, and the intended audience. So what each of them means. The intended application is what exactly we want to analyze. The purpose is why. The system is where do we draw the line, and the intended audience, who is going to read our report. This stage comes with a whole list of terminologies, which we'll explore in the next slide. So to begin with, the function. Function is the use of the product or the service that is being assessed. For example, let's suppose that we were focusing on artificial outdoor lighting with daylight spectrum or for an existing European fittings. Then we got the functional unit. It specifies what is being assessed, relating to the function of the product or the service rather than the physicality of it. This should be very clearly defined and, of course, quantifiable. In our example, it would be, for instance, to light 10 square meters with 3,000 lux for a specific amount of hours with a light that is reflected to the specific amount of Kelvin degrees. Then we have something called reference flows. These translate the abstract functional unit, as we saw it before, into specific product flows. So flows of product that will deliver comparable results of different alternatives. So in our example, for instance, we got 15-day daylight bulbs of 10,000 lumen with a lifetime of specific hours compared to 6-day type bulbs of similar lumen but with different lifetime. Then we got the product system. What is the product service life cycle, and what are the stages that we have taken into consideration? And the system boundaries, it defines which aspect of the life cycle will be included in the study and which are not. So as you understand, a life cycle can be quite demanding in resources. So you cannot always do a full LCA. So what is the approach you're going to follow? So we start with the very rapid life cycle approach. We call it environmental analysis, and the reason is that we don't follow strictly all the rules of a life cycle assessment. So it's better just to call it environmental analysis. It's a rapid. We call it level 0. It's based on Excel. We have multiple assumptions on data. We have an approximate solution that will just give us a baseline, and it's focused internally. So no rules. It's only for our own discretion. And the audience, usually it's us or the or organization. Then we further move along. We have an intermediate life cycle assessment where we've got measured data, fewer assumptions, but still assumptions. It's a fit to purpose and still has an internal focus. And then when we go all the way to a life cycle assessment, this means that we have external communication. So be very careful. When we refer to external communication, you always have to follow the standards and the guidelines, because what you have to do is to prove that you follow these guidelines. And the way to do that is through third-party validation. So in a full life cycle assessment, you would expect to see a full life cycle assessment inventory, primary and secondary data. We're going to talk about this later. Usually, when we have comparative studies, you have to do a full LCA because you have to be able to compare to those two things and build confidence on your claims. And they have to be externally reviewed and or published. So how do you use it? An LCA is quite complicated and time-consuming when it's done correctly. It is important to set it up for success by following the 4 stages. And the 4 stages are, of course, as we saw before, the goal and scope definition, the inventory analysis, and the impact assessment. And as you see, this is constantly linked with interpretation. So that means that for each of the stages, we have to go back and rethink what we do. And there are multiple approaches, starting from the raw material extraction, cradle, and we can go through all the way to gate, where we take into consideration the materials manufacturing the product. Gate cradle to gate, it's when the product leaves the premise of our industry. Then if we take into consideration the usage stage and the end of life, we're talking about cradle to grave approach. And if we somehow manage to all our materials be feedback and become the raw materials for the generation of a new product, we have a full ecological loop, or cradle to cradle, as we call it. So here we see a simplified example of the boundaries. The product system is having all the raw materials, the energy, transportation, use, packaging, and many other aspects of the product. And then we draw the line, the system boundaries, only the things that we're going to look into. So we see that we have selected very few things. So, and then the next step is the inventory. The lifecycle inventory is also referred as LCI. Every assessment requires an inventory of data, either from an existing database or things that we're going to collect during the assessment. And if we collect data on the assessment, it's called primary data. If we take it from existing database, these are secondary data. They should account for every input and output at each stage. Is the one that we saw before. For each stage, we should capture the inputs and outputs, and this is what it means. And it should be within the defined system boundary, including, of course, raw materials such as water, chemicals, etc., energy and sources, and emissions. And of course, not to be underestimated, but this can be quite complex. Other considerations is where will the data be collected from? What is the quality and accuracy of the data? Can those data be verified? Is it an exact or is it an average? Is it an estimate or based on an assumption? So of course, there are standards and guidelines that can support us during this process. It's not that we have to reinvent the wheel. In the baseline, we got the ISO 14040. It is there for general SA issues, basis, or other guidelines. Then we have the International Life Cycle Handbook, which it's built for more specific guidance that is not dealt within the ISO. Then we have the single issue. It's guidelines for specific impact categories, such as carbon emissions, etc. And then, as David talked about, we have the PCR, which is product category rules. Rules that are developed in order to be able to assess specific products that fall under these categories. So what type of data will you need to collect? Well, it depends on the goal and scope of the life cycle assessment. Things that you should generally consider, though, is it going to be marginal or average? What are the system boundaries? Where have you drawn the line? Allocation rules. Allocation is really important, and the best example I can think of is the cow. If you're doing a life cycle assessment of milk and meat, then how do you allocate all the carbon emissions that the cow was responsible for to those two different products? And this is where we use allocation rules. Functional unit is the one we referred before. The data should have geographical representativeness, so only data from your region. For instance, if you're doing an LCA in the UK, it's a big mistake to use average European data for electricity. Are they temporal, so recent, future, etc.? Should you consider uncertainty? And what is your available time and budget? And usually that is the one that actually draws the conclusions to what you're going to use. So if you want to collect foreground data or primary, then it needs to be a little bit more specific. The approach that you should follow in that stage is that you should establish a communication channel with your factory suppliers, etc. Because what you need is good communication to be able to access all this data. Ask for a flowchart. It's the simplest way for people to tell you where you're wrong. They will give you the flowchart, or you will create a flowchart. They will tell you where you're wrong, and this is the best way to capture information that somehow they didn't think it would be beneficial for you to know. Try to understand the terminology and the weight data that is normally collected. People that do this for many years, they know very well what type of data you might need, what terminology they use. So try to use their experience in your advantage. You can also develop a questionnaire that is concise and understandable, so it can go back and forth and you can get the data collected easier. And always process your data with extreme care. check that the answers make sense, ask for clarification if you don't understand something, and of course, document each step of the process. So in the impact assessment, the life cycle impact assessment is the culmination of all the necessary data to produce the impact results. There are many categories under which this impact can be displayed. An impact category pulls the results under one unit of measurement in order to allow comparison. For example, kilograms of CO2 emissions equivalent could be used for assessing climate impact. So long story short, impact assessment is just quantification of the impact in the climate. And there are different categories that we can use in order to capture different types of impacts. And a key stage is the interpretation and improvement. The interpretation stage is where we identify key issues in relation to the greater impact of the environment. This should always allow for recommendations to be made for improvements. Reporting should always be in relation to the goal and scope that we originally have set out. So this is why this stage was in alignment with all the other stages, because when you do the LCA, you should always try to be in alignment with what was the original goal and what is the type of information you want to convey to your audience. And different audience needs different type of information. And of course, it's the interpretation phase should also perform checks for completeness, correctness, quality, and anything that could have gone wrong. We have a case study. It's a beverage packaging, and I'm going to go through that fast because I don't want to take too much of your time. In our example, what we have is 4 different types of beverage packaging. We have one made from carton, one made from HDPE plastic, the other one from PET, and the typical glass. So in our example, we have the comparative study. And we're using an example of Tetra Pak that is publicly available, and in order to be able to describe. And what we have here is captions of the description of the life cycle study. So the first thing that we see is that the goal of the study is to conduct an LCA analyzing the environmental performance. So we directly know what the goal of the study is. And then we see the keyword compared. So what does comparison mean? Third-party validation. So if we go through the whole report, we'll see how they managed to have third-party validation. Then we're talking about the comparative results and their intended use. So we already defined the intended use and the intended audience. The intended use is to be used by the commissioner, and the audience is information purposes of customers, etc., and etc. So the study are therefore returned to be disclosed. And of course, we're talking then about the function examined in this life cycle assessment is the packaging of beverages, and the functional unit is 1,000 liters packaging volume for chilled or ambient beverage. So we see that we have a specific function, and then we have deriving functional unit for comparison. And the interesting thing is that although we're talking about small beverage packaging, so let's say half a liter or 1 liter, the functional unit is 1,000 liters. And that is the way we can actually have comparison between things that are different. So what we see now is the system boundaries for that very specific example. We see that we have the material production where we take all our raw materials and we use them to actually produce what we want to produce. And then we have the production and packaging stages where we see different stages that we manufacture this container. Then we got the filling, then we have the distribution and end of life. And then we see something called credits. What is that? So credits is a way that we can actually measure our environmental impact, but the positive aspect of it. So let's suppose that we have our beverage is responsible for 10 kilograms of CO2 emissions during the whole life cycle. But then, because we use it in order to displace hard coal in the credits, that displaced hard coal is responsible for 1 kilogram of CO2 emissions. So all we have to do is to take the 10 kilograms and then take 1 kilogram out, because that is our credit. So our total is 9 kilograms. And this is how we use credit usually. Inventory analysis, the packaging systems and scenarios. So for instance, what we see here is all the data that we have to capture in our inventory analysis in order to be able to conduct this life cycle assessment. And you can see that we have a lot of information regarding the packages. We got about the cups, materials, and other, or even the pallets that we're going to use. So all these are part of our system boundaries. Then we got the lifecycle inventory data. So it's an overview on the inventory process and datasets used in this specific study. Interestingly enough, we see that we see where we get the source we get the data from, and then we have the reference period, so we know how old it is, and of course we know if it's secondary or primary. Just to remind you once again, secondary is when we're using a database that already exists there, and primary is when we collect our own data based with our suppliers, our data selection process. And yes, this can be much more difficult, but it will give us much more detailed data. And end of life system description. It's many times where people refer to end of life, they just say, oh yeah, I'm going to recycle it, or don't worry about it, it's 100% recyclable. Truth be told is that many times we have to develop a full scenario. What you see in this example is a full scenario of how you model end of life. And you see that even if it's carton, 47% ends up in disposal and 53% in collection. And in that specific case study, they have modeled the whole end of life in order to be able to have confidence in their assumptions and in their numbers. And then we have impact assessment, different impact categories. So we have climate change, we got ozone depletion, and many other categories, and the units that we use in order to quantify these impacts. So this is the life cycle results. And as you see, it's a really big table. Usually it's even more data that shows us multiple numbers, multiple results, and how can we understand those? How can we interpret those? The easiest way is to go back to what was the goal of the study and try to communicate and convey that message that was from the goal all the way to the end. And in our example, for instance, we keep it simple, and we see that each of the 4 options is responsible for specific CO2 emissions. And as you see, it's per 1,000 liters. And this is why, because that is our functional unit. And that is the way we can actually be able to compare very different things, but have comparable results. So let's see some conclusions of them. We see, for instance, that carton systems are the ones that are the more, they show different environmental performance depending on different segments, and they have the lowest ones. We see that carton show the lower environmental impacts in all segments regarding climate change. Only regarding water, we see that the PET is better. Interestingly enough, the utilization of plant-based polyethylene instead of fossil-based polyethylene does not deliver clear results. And that is really interesting because many times we see that sustainable products are being marketed as sustainable, but we cannot quantify how well or what is their impact and what is exactly what an LCA can do. And finally, in this study, it's shown that closures can contribute considerably to the amount of overall life cycle. So what type of lid we're using to the closures, that also plays a key role. And thank you very much. I will pass it now to David.
So just going to talk a bit about what programs are available, and this is in terms of software. So now there's 2 components you need if you are going to do an LCA yourself. One is the software, the second is the databases, and OpenLCA, which is the first on the list, is free of charge, and you can download that from the website. Other software, some of these are commercial, like Gabi and SimmerPro, you have to pay for it. But all of them need to make use of a database, and these databases are built up. A lot of it's academic work, which has been validated to show that the data is meaningful. And these databases, there's a few, but the most common one, which most companies seem to use, and most organizations, including us, is EcoInvent. And that provides databases on the materials, not so much on the material extraction, but really on the materials and the various processes you can use. And it puts those values can be poured into your software. So as Aineias said early on, one of the starting points is actually almost like a process flow and doing the mapping out. And from there, you can work on information you need. And it's how the software and the databases come into play. So personally, as a team, we use OpenLCA and we use EcoInvent. I know Aineias also uses SimaPro. So we are open to try different software, and there is sometimes subtle differences in the values you get. And that's one of the slight concerns with most software. The way it calculates things can be slightly different, not massive differences, but subtle differences. What help is available? And this is really coming down to the last slide. As we mentioned, an MMIS, so you got Aineias, you got the team, Gregor, you got myself, all of us are available to either help you or at least signpost you to where help is available, can be support you on your journey. There's also quite a few great organizations. Some are great. I already mentioned I showed the picture of the circular economy. That was the Ellen MacArthur Foundation. But there's also other ones like Science-Based Targets and the Carbon Trust, who are very proactive in helping companies and also providing a lot of information on the websites to get companies and individuals, in fact, started on their journey. So just a list there, and of course this is all available on YouTube, this video, so our recording of today, so you can have a look in your own leisure time. And really, that's the last question. It's been that's the last slide. There's been a few questions we've answered as we've gone along, but we've still got time now for any more questions or any clarifications, because it is a lot of terminology, a lot of different concepts. And I noticed already people have started adding some to the chat. Thank you.
Thanks, David, and thanks, Aineias. I've been keeping an eye on the chat, and thanks to David and the team for answering some of those questions as we've been going through. Lee, thank you for your input. I think I've got a couple here that we haven't got an answer for, so I'll just throw them up to you guys if you wanna pick these ones off. So, how long did it take to undertake the LCA for Tetra Pak? Who was involved, and how was that funded?
Yes.
This report has it's been funded through the Tetra Pak company. It's an open access report, so everyone can access it. The way it was validated is it was co-developed from the company and the consultancy company, and all the results are open source, and we can actually they're access to everyone. I don't know if that's enough.
Thanks, Aineias. I'm just seeing that Lee's just jumped into the chat there, and she's just looking for a link to that Tetra Pak study, and she's just popped it into the chat there as I've been mentioning. So again, thanks, Lee, for your inputs there. I think as far as I've seen, I think we have picked off the majority of these questions. I'm just quickly scrolling back because there was one I wanted to just throw out there again. The third parties giving sustainability accreditation for companies or institutions, we did get a bit of feedback as Lloyd's being an example of one of these organisations, but I wondered if any of you guys had anybody else that you wanted to add on to that list.
I mean, there's quite a few consultants out there who are doing the initial LCA and going into the companies. I'm not familiar how many companies actually are then used as the auditors, but definitely there's a few around Scotland. One immediately comes to mind is NetZero Nation, which is a Scottish-based one. But Aineias, you want to add any more, or Lee, to that?
From my side, all I can add is if you are a researcher, it would also be beneficial, and if you have done a life cycle assessment, to try to publish an article on a journal related to life cycle assessments, because the people there are experts, so they can review your LCA and being able to give you the relevant feedback and also validate it and review it. So if you don't want to go through a consultancy and what you're doing is research, I would suggest to have a look at that as well.
Thanks, Aineias. Just another question popped into the chat. Within a supply chain, where do you draw the line between your Scope 3 emissions and the next link's Scope 2 emissions to avoid double counting?
I think this comes back to how your boundaries are defined. I mean, we had this discussion at a workshop yesterday as well. So I think it's all about boundary definitions. You're right, you can double count if you're not careful, and it gets even more confusing. Lee, you want to add anything to this? Can you just do some nice slides on boundary definitions? Is Lee gone quiet? Aineias, how to define your boundaries, is it, to avoid double counting?
Well, as you said, it's a matter of boundaries. In general, there is a principle that Scope 3 emissions are direct emissions of other companies, so your suppliers. So if you have defined boundaries with your suppliers, then you should, in theory at least, be able to draw that line easier. There is the greenhouse gas protocol, as Lee mentioned in the chat, that should be able to give you a good understanding or guidelines. And of course, if you are in question of if you should capture that, yes or no, then there is always support, such as the Extend team, Aineias, or people that they can actually support you to take that decision, because sometimes it can be a little bit more tricky.
Thanks, Aineias. Again, a couple more popping in here. Can you provide a ballpark figure as to how much consultancy LCA might cost? It's always what it comes down to, doesn't it?
It is. I'm trying to work out how. Aineias, how long does it take? I mean, we can work it. We can't talk about salary, but how many hours does it take to do an LCA on what, from your experience, the ones you've done?
Well, if you remember the slide that we showed before, there is an LCA that is in level 0 and an LCA that's in level 1. If you go through the 70 pages of the Tetra Pak one, LCA, it shows that it's a work, and if you see the dates, it's a year's work. So constantly they have to take data. So it really depends. An LCA that it's rapid, or let's say something that internal, can be focused on only the key issues, but that's environmental analysis. The farther we go down, the more we collect data and the more resources we put, that figure will only just become greater. If you want to do that with a much lower cost, what I would suggest is being able to identify a funding opportunity. There are multiple funding opportunities to support you with product design, quantification of your environmental impact. Anyways, is tremendous in providing this through the product design team and other teams. So we can also be able to support you finding your funding opportunity and limiting that cost to an extent.
I'm sorry, Fraser, we can't give you an exact answer because it's like how long is a piece of string? It really depends on the application. So, I mean, this is part of our projects, is to deliver this, to companies. So we don't really know exactly how much we should be charging if we were charging. So we're very bad business people.
I think that picked off the follow-up question that came in there as well about how long it would take to do an LCA for specific parts being manufactured. For example, an EV car motor part. Again, I think that how long is a piece of string is probably quite a good answer for that one too.
It is. So for Russell, it depends how many levels you want to get down to. I mean, we have looked into automotive parts, and it depends on the complexity as well. So not an easy one. And from research which the team's been doing, it's also getting information. So for example, parts are made in China. What does that mean? Is the material from China? Is what process they use, or elsewhere in the world? It's getting that kind of information and the fidelity you need, which is not always forthcoming. I see LCA as a way to force companies to start asking more questions about their supply chains as well. Where do things come from? How is it made? What's the material? How's it extracted? And we see that it's going to be forced upon the whole supply chain. So there's going to be a lot of level of information required to make, better. The more information you got, the better your analysis is going to be.
Cool, thanks, David. And I think we've just hit 2 o'clock. I think we've got one last question. This is the last one we're going to throw out to you guys before we bring things to a close. How are you going to encourage industry or companies to follow LCA?
It's going to happen, Russell. It's going to come down from the top, because it all goes back to the companies themselves and show that the big companies, the tier ones, have to show that they are, or the OEMs, that they are net zero. The reason they're being pushed is legislation, but also pension funds are also pushing for companies to be more green. So it's going to come top down. If you don't go through the process of showing your LCAs for your products, you lose the business. They'll go to a greener supplier than before. Years ago, I worked on the cardboard box manufacturing line, and we got ISO 9000. We got a £1 million order because we were the only supplier to that company which had ISO 9000. The other competitors lost the business. So it's going to be top down. I'd be very surprised. Very few companies at the bottom will start pushing up. It's going to be driven from the big companies.
Yeah, I totally agree, David. I think we'll see some of these changes getting forced down from the top over the next couple of years, I think. So definitely. Look, I think that's great. We're going to bring things to a close now. I'd just like to thank the team for the presentations today. Thanks, David. Thanks, Aineias, and thanks, Lee, and the team for helping out in the chat. Thanks also to Debbie and Laura for the marketing for hosting the session for us today as well. I hope everybody has enjoyed the session. If you've got any follow-up questions or anything you want to discuss further, drop me an email and I can put you in touch with David and Aineias as required. Thanks, everybody.
Thank you.
Thanks very much, Greg. And we'll just bring the webinar to a